What, you're not impressed? So let's do it again. Now the thing is, you'd expect the water to come out, wouldn't you? But it hasn't. Now the question is, why is that? Rubber is a polymer. Now on this balloon, you've got the dark parts here and here, and that's the parts that isn't stretched as much. So what I can actually do is take a really sharp object, if I'm lucky, stick it through there. Look at that. Now it's inside, then it hasn't popped. You normally think balloons would pop when you put something sharp into it. You can find that other end here. Yeah, there you go.
Ah, the sausage finger.
You like the sausage finger?
That is my favourite finger.
Go on, you do the sausage finger first.
Well, so you just kind of hold up your fingers in front of your eyes like that, and you basically see a sausage. And depending on how fat your fingers are, you get different types of sausage. So the skinny ones, the most you will have little chipolatas. Some of you will have sort of the more generous Cumberland sausage. But overall, this idea that you've got this floating sausage, and what's great is, well, everyone looking at you thinks, wow, they're doing something really important and scientific. Well, actually, all you're doing is just creating a little sausage. But what's the science behind that, Hugh?
Because you've got two eyes, it becomes a sausage at some points, or you can pretend that there's a sausage there.
Two images combined within your brain to form this kind of...
Yeah, exactly. Well, you need just a little bit of water and empty it onto your plate. Drop a little bit of pepper onto it, anywhere onto it. Just get a little bit of washing detergent and put it right in the centre, and you'll get that shockwave effect again with all the pepper.
So what I'm going to do is just pour the water with the food colouring into the middle of the plate. Light the candle, pop the glass on top, and watch what happens. Here we go. There's the water starting to be drawn up. Candle's gone out, all the oxygen's been removed, and we have now seen that water can travel uphill.
You need a good mix of colours to get that tie-dye effect. So I'm going to use some pipettes just to make sure I got that nice even spread. A little dab of each. It looks amazing already, but it doesn't look anywhere near tie-dye. So for that, we'll just use a little bit of detergent. As it goes in, you'll notice all of the milk and all of the colours will start to spread. The surface tension of the milk starts to break down, and the food colouring gets pulled all the way across the bowl.
So let's start making our own hovercraft model. Okay, first of all, you take the CD, your blank CD here, and what we want to do is cover up the hole in the middle here with the sports bottle cap. Now, we're just going to glue that on there, very, very simply. You want to make sure the cap's closed, first of all, blow up our balloon, and then carefully pop it over the top of the cap there without letting the air out. There we go. Okay, now, hopefully I can let go of that balloon, and the air should stay within it. When we open up the valve on there, the air from the balloon is forced out through the hole in the middle of the CD, and as we keep pushing more and more air under it, there's only one place for that air to go, and that's out around the perimeter of the CD itself. Let's see that in action. You can actually feel just a little bit of air escape around the side of the CD.
If you've got an uncooked egg, something like this, if you spin it, then the fluid moves around and dampens the movement itself. So after a while, it'll slow down and stop. You can't even get it spinning that fast. Whereas if you've got a boiled egg, the properties inside have changed, the proteins have uncurled and bonded together, and that means that there is no movement inside. So when you do that spinning action, it doesn't actually stop. So that's the good way of telling which is a hard-boiled egg and which is a raw egg.
Your film canisters here, take the lids off. All you're going to do is cover the bottom of each of the canisters. You don't need a lot, you just need to cover the bottom of it. I'm going to turn them over now one by one, giving them a wee shake to get them excited and hopefully speed up the chemical reaction. So here we go. So as you can see, the chemical reaction has taken place inside and is nearly taken out my camera woman. What's happened inside is the sodium bicarbonate is added and has reacted with the vinegar, created carbon dioxide inside. Now, as we know, gas takes up far more room than any other states of matter. Carbon dioxide is built up is now inside a contained space. It's building up far too much, and the pressure ended up blowing the top off, and we get popping canisters. So there you go.